So what we have right over here, we have the vector u, and we've defined it by giving its x and y components. It's a two-dimensional vector. And we have the vector w, and we've graphed them. The vector u, its x component is 2, its y component is -1. So if we put its initial point at the origin, the terminal point, or its head, will be at the point 2, -1, which is right over there. And for vector w, it's -5, 5. So its x component is -5. So if we start at the origin, we would move 5 to the left, and its y component is +5. So we would move 5 up then to get to the head of the vector, or to get to the terminal point. Now, given these two vectors, what we want to do is evaluate what 3 times the vector u plus 1/5 times the vector w is. And I encourage you to pause the video and give a go at it. Well, 3 and 1/5 are scalars. They are going to scale these vectors, and we're going to see that happen visually. So we're going to scale up vector u by 3. We're going to scale down vector w. We're going to multiply it by 1/5, and then we're going to add the resulting vectors. So let's do that. So when we scale vector u by 3, we could just view this as 3 times vector u, we know, is a vector 2, -1. And so that's going to be, we could write it this way. So let me write the 2, let me write the -1. That's going to be 3 times 2 for the new x component once we scale it up, and 3 times -1 for the new y component. And of course, that's going to be result in the vector 3 times 2. Our new x component is 6, and our new y component is going to be -3. And so let's plot that. So everything I've done just now is that part of the expression. So the vector 6, -3, if we started at the origin, we're going to move, so let's see, we're going to move 1, 2, 3, 4, 5, 6 in the x direction, and -3 in the y direction. So 1, 2, 3. 1, 2, 3. So we get right about there. So there you have it. This is the vector 3u. We're at 1, 2, 3, 4, 5, 6 in the x direction, or 6 to the right, and then we went down 3. 1, 2, 3. In the y direction. And notice, it's in the exact same direction as vector u. It just has 3 times the magnitude. That's vector u. That would be 2u, and then we get to 3u, 3 times the magnitude. All right, now let's figure out what 1/5 times w is. So 1/5 times w, well, let me just write this. It's going to be plus 1/5. W is the vector -5, 5. And so this is going to be plus, so it's going to be, let me write the components down. So it's going to be plus 1/5 times -5, and the y component is going to be 1/5 times 5. And so that's going to be plus, whoops, I wrote 1/2. Brain's not working properly. 1/5 times -5, and 1/5 times 5. And so this part right over here is going to be 1/5 times -5 is -1, and 1/5 times 5 is +1. And so this new vector, 1/5 w, is going to be w scaled down. And so it's -1, 1. If we started at the origin, so -1, 1, we get right over there. And notice, it's going in the same direction as w. It's just 1/5. It's just 1/5 as long. And now we just want to add these two vectors. So if we add them by just looking at its components, the resulting vector, let me do this in a new color that I have not used yet. So the resulting vector, we're going to add the corresponding x components. So it's going to be 6 plus -1. 6 plus -1, and the resulting y component is going to be -3 plus 1. -3 plus 1. And so the resulting vector is going to be equal to 5, negative 2. And we could also see that visually. If we start with this blue vector, 3 times the vector u, and we were to add the green vector, 1/5 w, well, we were to add that, we would just start at the head of 3u. We would, when we are going to add negative 1 comma 1, so we're going to move 1 to the left and 1 up, we're going to get right over there. So let me see if I can draw that. So just doing a little head to tail method right over here. So the head of the first vector is going to be where the tail of the next vector starts that we're adding. And so the resulting vector is going to be, if we started at the tail of the first vector of 3u right over here, or at the origin, and then we bring it to the head of the second vector, we get, once again, the vector 5 comma negative 2. Its x component is 5. We move 5 to the right, and we move 2 down.